Okay, Ryan, concerned about that our schedule online or in class. So I will up the our schedule. So today we are online, online only. This file is updated on Moodle. So you can download the syllabus and then you can see this updated schedule. So every other week, today online, next to Wednesday in class, online in class, and so on. And then after Thanksgiving, all online like this. Maybe before the Thanksgiving start online and then all online like this. Is it okay? Okay, good. And last week I asked you read these two cases and then try to answer discussion question. So it's kind of teamwork I asked. Is there any team to answer this discussion question?
I could answer on behalf
Okay, good.
So the first question, we kind of came up with the consensus that if we were the production manager for RMC, we would realize that we're assuming that the machinery is really, the machining system is very versatile. So number one, we'd want to look at the return on investment. If the project is only expected to yield anywhere from 10 to 15%, their previous projects, they know that they're confident they can make above and beyond 15%. So they're kind of taking a gamble and they really should work out the numbers. If you divide up those figures they gave you for like the savings and stuff like that, if you kind of project that the cash flows from the new FMS system are even, you can do a calculation for payback period and you'll realize that it's going to take longer than the 5 years for this investment to pay itself back. So it really wouldn't be in the best interest for the production manager. But if you were the salesperson trying to get this flexible manufacturing system in place, you would push for it. But if you're working for a company, you wouldn't.
Good, yeah. Very good answer, yeah. Any other team different answer? Is it okay? Okay, good. How about second case? Any team?
I can do it for our question number 2, or for team number 3. Okay, so question is, why do you think that major auto manufacturers do not build ambulances? And our group found out that they do not build the ambulances due to the complexity of them. Every single unit is customly made, so the cost is very expensive and it requires a lot more work than a normal car. They would have to be focusing on the customer's needs and wants of such a small market, like niche market, and it's also set up to be like all the parts needed cannot normally be stored in like a normal manufacturing place. So if they end up spending more money for equipment, machinery, parts, and labor, then they're not going to be able to sell a lot, so they need to keep that all low.
Mm-hmm. Okay, good answer. And any other different answer?
This is Ryan. For team 4, we had, oh, sorry, can you hear me?
Yeah, I can hear you.
Yeah, so for the second question, what's an alternative process strategy to assemble? We, team 4, had consider outsourcing, building like standard processing tasks. So when the product arrives, it's, I don't know, something like 20% already put together, already manufactured.
Yeah,
So we had that as an alternate process strategy.
Yeah, my opinion, if they can use cellular layout, then it will be better, make a better process for the like a customization product, like ambulance and so on. So we will talk about that cellular layout next week. So I will talk about this one more next week. Okay, any other? Okay, good. Then move to today's lecture. Let's go to. Okay, chapter 11 and 12 today, 2 chapters. So chapter 11 is about supply chain management. Supply chain looks like a network from supplier to customer. So this one example of beer industry. So from farm and other suppliers, plants, then they also suppliers for the brewers, and then move to like a distributor, and then like a Sam's Club or a retail store, and to a customer. So supply chain is a term that describe how organizations are linked together from supplier to customer. And then supply chain is network from a supplier to customer. And supply chain management. This is a total system approach and coordinating activities. What kind of activities? From supplier to customer, like receiving, sending, holding, and so on. So managing activities in a supply chain to make it better, cheaper, faster. So goals of the supply chain management is reducing cost, cheaper, time, faster, and then improving quality better. So this supply chain management is part of operations management to make it better, cheaper, faster. And then measuring supply chain performance, measure if the supply chain work good or not good, using inventory turnover. Inventory turnover equals cost of goods sold divided by average aggregate inventory value. Cost of goods sold to produce and to sell, they need material cost and employee person and equipment and so on. And then average aggregate inventory value, including work in process, material, and final product, and so on. We will talk about inventory next chapter, chapter 12. And then weeks of supply. using this weeks of supply, we can measure supply chain performance. Weeks of supply equals average aggregate inventory value divided by cost of goods sold. This one is numerator, denominator flip over of this inventory turnover, and then times 52 weeks, because a year is 52 weeks. So example, net revenue 18,243. Actually, this one is $1 million. And then cost of revenue, production material, material on hand, and so on. So inventory turnover equals 14,137. This one. Cost of revenue is the same as the cost of goods sold. And then inventory, aggregate inventory value is 234, material, and then work in process and final product inventory. So inventory turnover equals 5178 tons per year. And then weeks of supply, flip over, and then times 52 equals 1.004 week. Okay, if a company's, where is cost? Okay, company A's inventory turnover is 5178, and then except supply 1.06, and then if company B's inventory turnover equals 40 tons per year, and then if weeks of supply is 1.2 week, like this, then with this inventory turnover and then weeks of supply, which companies supply chain work better, A or B? What do you think? A better or B better? Anybody?
Is A better?
A better, yeah. Because A, because the ton means more ton means work faster. And then this one, weeks of supply, the material, whatever, stay in the supply chain. So shorter, work faster. So more tons and shorter stay in that supply chain. So company A's supply chain work better. Okay, clear. And go next. Okay, outsourcing and vertical integration. I think we mentioned about outsourcing earlier, I think, but many companies use outsourcing. If we can, if others can do better than us, faster than us, and cheaper than us, then let our function send out and then let them do it. That is outsourcing. If they can do better than, faster than, cheaper than us, then send our function out and then let them do it. That is outsourcing. But if we can do better than others, faster than others, cheaper than others, then bring inside. That is vertical integration. So many cases now, one of cases of vertical integration is Hyundai has subsidiary. One of the subsidiaries, the name is MOBIS, M-O-B-I-S. That is a part company of Hyundai. So Hyundai can do can make a better part than others. So bring that function inside, not actually inside of Hyundai, but make a Hyundai subsidiary and then let them make it. So it looks like outsourcing, but I think that is kind of vertical integration. Hyundai has that part company, MOBIS. So looks like outsourcing, but it is actually, that is the vertical integration. Supply chain risk and tactics. Supplier fail delivery risk, and then risk reduction tactics. Use multiple suppliers. When I was in Alabama, then I know Hyundai and Kia there. So one of the case of this supplier failure case, one time one of the Hyundai suppliers was fired. The plant was fired. So at the time, Hyundai usually manufacturing companies has 1 month inventory. So 1 month was okay, but because of that supplier to rebuild, it took 3 months. So other 2 months brought part from Korea, China, and so on like that. So after that, the Hyundai bring another supplier near that place. So using multiple suppliers to reduce this kind of risk. And then quality failure, careful selection of the supplier, and then test and evaluate suppliers like every year and so on like that. And then outsourcing, the same, using multiple and then select carefully and so on. And then logistic delay problem. This one also using a multiple method, transportation method, and the multiple suppliers near the plant, the main plant, and then from like international more suppliers and so on, and distribution the same, and then information using a redundant database, and then political risk, then use more countries, suppliers, and the economic, the same, more countries, suppliers, and this one also the same. So there are many supply chain risk and tactics. And supply chain strategies. Based on demand uncertainty and supply uncertainty, use different supply chain strategy like this. First, demand side uncertainty based on types of product, functional products. Example of the functional product is grocery, gas, and so on. Normal life, regular life, we use something every day and then often. You know, life cycle, product life cycle. Product life cycle looks like, oops, not good. Looks like life cycle 4 phases. So introduction part, growth, and mature, and then decline. So this life cycle of this functional product is long, more than 2 years. And then small contribution margin. Contribution margin is like this. We will talk about break-even point later. So this is fixed cost, and then variable cost increase. So this one is total cost, and then this one is revenue. And this point is break-even point. So before this break-even point, price minus variable cost is kind of margin. We call this part up to break-even point. This part is contribution margin. And then after this point, this area is profit. Contribution margin means contribute to offset the fixed costs, such as machine cost, facility cost, and so on. That is small, because this life cycle is long. So small by small, offset this fixed cost is okay, because life cycle is long. And then lead time for this functional product long, that is okay, because the life cycle is long. But innovative product, another type of product is innovative product, such as fashion apparel, short life cycle. This year's fashion may not fashion next year. So fashion apparel or something fancy product, the design product, life cycle is short. So because this innovative product life cycle is short, contribution margin for this should be large. Because life cycle is short, faster offset fixed cost. So contribution margin for innovative product should be large. And then lead time for innovative product should be short. Because life cycle is short, lead time should be short. And then next, about the supply side. There are two types of supply chain: stable supply chain process and evolving supply process. If you have an old version of the cellular phone, then to buy accessories such as the cover or something accessory, if we go eBay, then there are so many accessories, and then the price is very cheap. But newest model, this time Samsung Galaxy is S20 is the newest, and then iPhone is 11, and then 12 will come soon. So if you have the newest version of the cellular phone, then not many accessories, and then price is high. Like the stable supply process, like old version, the market of that product is already mature. And then evolving supply process, new, and then newest. So the process is fluctuate. So stable supply process, the uncertainty is low, but evolving supply process and supply chain is fluctuate, not stable. So there are 4 dimensions based on demand uncertainty. Functional product uncertainty, demand uncertainty is low because there is no demand there. So anytime company can sell, but innovative products such as fashion apparel, anytime it disappears. So uncertainty is high. And supply side, stable process uncertainty is low. Anytime producer or manufacturer can get supply. But evolving process supply uncertainty is high. Sometimes it's harder to get supply. So based on these uncertainties, efficient supply chain strategy, responsive supply chain strategy, risk hedging supply chain strategy, and agile supply chain strategy. First dimension, demand uncertainty and supply side uncertainty, low and low. That case, company can get supply anytime, cheap, and then anytime sell because there is no demand. So don't worry about the supply and demand. Just try to make it cheaper. So focus on cost efficiency. Try to make it cheaper and cheaper. Example of this dimension is grocery, basic apparel, food, and oil and gas. And risk hedging supply chain strategy. Demand uncertainty is low. There is demand, but sometimes it's harder to get a supply. So on supply uncertainty is high. So try to reserve resource. So try to aim at pooling and sharing resources, such as the hydroelectric power and some produce. They are depending on the weather. So they try to build a dam to reserve water and so on. And responsive supply chain strategy. Supply side uncertainty is low, but demand uncertainty is high, such as fashion apparel, computer, and so on. So try to move fast. So make the company flexible. So that is responsive supply chain strategy. And last dimension, both side uncertainty high and high. So try to reserve supply and then move fast. So we call that agile supply chain. strategy, such as product of the telecommunication, high-end computer, and semiconductors. And then how strategy impact supply chain decision. So if they focus on make it cheaper or make it faster and make it better. So supplier selection. So if they can make cheaper than us, select faster than us and better than us. And then inventory, try to minimize inventory, and then using a buffer and minimize inventory. Network, when select network cost, if they can make it cheaper and faster and then better. And then design, maximize performance, because they focus on cost and time and quality. If they can make it difference than others, and so on. Okay, managing supply chain, lot size reduction. Sometimes lot size means when we place order one by one or a bunch like that. Depending on the products, lot size, large, if they can use economic purchase price, many, but delivery fast, then use smaller size. And then single stage control of replacement. It's like I think we cover about the process, then make the order or make stock. Based on that, pull or push. Now we will talk about push system and pull system later. So using a single stage control of replacement when we need an inventory, then how can we get that inventory about that? And then using VMI, vendor managed inventory. It's like an Amazon. Early stage of Amazon, their business was controversy because of the overhead and the cost high, inventory cost high. So move inventory to each vendors. So sometimes when we order, Amazon send my order, but sometimes my order from vendors. So using vendor and then vendors inventory, they control Amazon's inventory there. So that is VMI. And then collaborative planning, forecasting, and replenishment, CPEFR. With suppliers work together for the forecasting, planning, and so on. And then blanket order or long-term purchase. Sometimes it's better long-term purchase. Sometimes it's better short-term purchase. So it's depending on what kind of product. So using long-term or short-term. Value density. Earlier, when we decide that network, then what kind of transportation we use in supply chain. Using this value density, we can decide. This is the value of an item per pound of weight. So like a diamond, 1 pound of diamond, very expensive. But then 1 pound of coal, this Scranton area is famous with the coal mining. I'm not sure how much, but 1 pound of coal, maybe less than $1. But the diamond, 1 pound, very expensive. So the value of an item, 1 pound, different. So there are 4 types of transportation method using air, trucking, and train, and then water, like a ship. Speed, air side is fast, and water side is slow. Volume, air side is small, water side big ship, large. And cost, air side is high, water side is low. And then if value density, like a diamond, high, then using faster and small high cost transportation. And then value density low, like a core, then using this side better. So using value density, we can decide which transportation method use in supply chain. Mass customization. Many different types of products, and then each volume are large, many. So many and large situation. How can we deal with this mass customization situation? Using this, postponing the task of differentiating. Don't make final product. Stop certain point, latest possible point, stop there. Don't make a final product. If I need a paint to paint wall, so we go Walmart or Lowe's, Home Depot, and so on. Then choose a color kind of card, and then give this card to a worker there. Then they bring white paint and then mix. So don't make a final product, stop there, and then customer orange mixed red and yellow. If customer asks green, then mix yellow and blue. So don't make a final product, stop here, like a component or module, and then later assemble and then make the final product. This is mass customization strategy. If it is a product, then same, using independent module or component like this, and then later customer come and then ask the final product easily and inexpensively and faster assemble or produce final product. And manufacturing process or service process using independent module. We will talk about the cellular layout. So using cellular layout, cell, then combine and then make the process. So cell or cellular layout can be independent module or process. and then we can make it change easily and faster. And supply network using the same module or component. Outsourcing companies can be module or component of supply chain or network. So using outsourcing companies and then combine, then make a supply chain. So they can move fast and then make it the supply chain flexible. Okay, that's all for chapter 11. I will show my previous kind of case study. Just a moment, I will bring up. This one was my case study about Hyundai subsidiary Globus. Then about the supply chain. So the company, actually Hyundai, and Globus is a Hyundai subsidiary. This company is like a logistic company of Hyundai. So using RFID technology, and then Hyundai actually use the global supply chain network. They call real-time location system. So using RFID technology, track supplies. So using RFID and this real-time location system, Hyundai and Globus reduce cost and then make it faster too. So it's like Hyundai Motor has reduced logistics related cost 8.1%. And then among them, this 68% save from improved transportation, and 26% from inventory management, and then 10.8% from labor cost. So using technology, RFID, and then the system they call real-time, where is now? Where is now? RTLS. So this is my case study about supply chain management. And then this one, this one is Korean, but others so using RFID, go. Company use on container RFID. This one is a reusable. So this container, you keep the RFID, and then at a gate, there is RFID reader, like an antenna. So the container pass the gate, and then automatically the system count, and then in a Globius company and then send it to the stock area, and then this one goes to Hyundai and so on like that. So using RFID technology, Hyundai and this Globius save cost and then make it faster. So this is now my case about supply chain. Not exactly like this, but similar to your team project for this semester, for this course and class. Develop on operations management case like this. I will give you another example later, more example later. So there is an assignment for chapter 11. This one, find supply chain management case from our Marriott University website, and then a library. And then, come on. Database A to Z, and go down to business. Source Premier. Need account. In search, you may type supply chain management, risk, whatever your interest, whatever. You may narrow down or specify about supply chain topic there, more specific. Then you will have a bunch of supply chain management journal paper articles like this. So any read, you may read like an abstract, then choose one of them. So the case about supply chain management. So a certain company, whatever manufacturing company or retail service company, such as Walmart, whatever companies, supply chain management case, find, then summarize. Use whatever supply chain management technique, tool, whatever, they make maybe faster, maybe cheaper, maybe better. So any benefit using any supply chain management concept, tool, whatever. So find one supply chain management case and then summarize. Just half of page. Summarize the supply chain management case, and then save and upload here your summary of the supply chain management case. Due is next Tuesday night. Is it okay? Doable?
Yep.
Okay.
Yeah.
So it's like a training you. How can you find article or journal paper? It's like preparing your final project. Okay.
Dr. Kim, is this a group activity or individual?
Individual.
Okay, thank you.
Okay. That's all for chapter 11, and then take 10-minute break and about 8-minute break. I will be back at 7, so come back at 7, okay? And then we will continue next chapter, chapter 12. Okay, see you.
All right, sounds good, thanks.
Okay, good. Okay, I'm back. Okay. On Monday, I teach research methodology. In research methodology class, I talked about this. R and R Studio. This one is analytic program, data analytic program, and looks like this one is R, and this one is R Studio. So using this program, we can do like statistics. Last year, and then I came to the Marriott University in 2010. Since that time, I tried to develop quantitative classes, such as business analytic courses and a certificate program. And also recently, now I'm developing a course using this R program, but there is no way to teach this course at Marriott University. But I like to teach this R Studio for our student. So if there is or there are students interested in, then I will teach. It's like a workshop, voluntary and free. Nowadays, you know, many companies ask workers if they can do like Excel analytic tool. So this will help our students to get a job, or even now they work. If they can do this, then it will help. So anybody interested in this course, then let me know. Email me. Then I think it will be between 10 and 12 sessions to cover all this R Studio. So I expect to start between mid and late October. And then it's like the one night a week. I'm not sure when, but then maybe Tuesday or Thursday night, 2 hours. So now I'm preparing the course. So after finish that workshop, even it is not an official from university, but I will make a kind of a certificate, complete this course. So later, if you need certified, if you can do R Studio, then you can use that certificate. Okay, this is kind of my advertisement. And next one is chapter 12. Okay, chapter 12 is about inventory management. Inventory management is one of strategic decision in operations management too. Okay, inventory, when we say inventory, the stock of any item or resource used in an organization, whatever manufacturing company or service company, they need an inventory. Manufacturing inventory, raw material, they need like rubber, wood, iron, and so on. And then components such as engine, instrument panel, and so on. And then we call MRO, maintenance, supply for maintenance, repair, and operating. We call MRO. And then work in process, kind of not finished product in process, work in process, and then finished product. They are manufacturing inventory. And the objective of this inventory management is find the balance between inventory, investment, and customer service. Actually, it's like a cost matter. So reduce cost, then how they can make it cheaper, and then improve customer service. Function of inventory, maintaining independence of operations. If they produce multiple products, then like type A, type B. So produce type A and type B. Then schedule is like an AB and AB. Then if the company has enough inventory of B, then they can change like A, and then later B and B, something like that. So if they have inventory, then maintain independence of operation like this for each product. And then to meet variation in product demand, if there is no demand inventory, enough inventory, then even demand surge, they can meet that demand. And flexibility of scheduling, same like this. AB, then enough inventory, then change schedule like this, flexible. And provide the safeguard. It's like a variation. If they have safety stock, then meet the variation of demand. And then take advantage of economic purchase order size. If they have enough inventory space, then they can buy large size, then like a discount. Okay, then next. When we say inventory cost, there are 4 types. Holding cost, if there is no inventory and then carryover, then they need the cost like handling cost, insurance cost, and so on. And setup cost, if they produce different types, then change the process, setup process, that is time and employee cost. and ordering cost when place order is like a shipping cost and so on, ordering cost. And shortage cost, if there is demand but out of stock, then lose opportunity. If we have inventory, then we can sell, but because of out of stock, lose that opportunity. So shortage cost is an opportunity cost. Managing inventory, when managing inventory, they use ABC analysis. Divide inventory into three classifications. Class A, Class B, Class C. Class A, inventory, the amount of inventory not many, 15% of total inventory, but the value of this inventory item is high. Even small inventory size, but the value is high, between 70 and 80%. And then Class B, medium value, and then not many inventory size. And the value is between 15 to 25. And then Class C, many inventory size, but value is small, like 5%. So based on inventory size and then value, classify A, B, C. That is an ABC analysis. So based on this classification, Class A is very most valuable inventory. So focus on much about this. It's like this. And, Class A, the value is high, but the amount is not many. Medium, B, and C, like this. So based on ABC, focus on more on Class A inventory. And cycle counting, using that ABC analysis, Class A count often, also months. B, like in the middle, less frequently count, perhaps also quarter. And then Class C, every 6 months, not often. So using ABC classification, count differently like this. Inventory system. Inventory system is like ordering system. So when we place order, how many we place order, then order, if we order Q, size Q, then inventory is Q. And then based on demand, how can we decide order size? Single period inventory system and multi-period inventory system. Single period inventory system use one-time purchasing decision. Decide order quantity, then use that order quantity, and then next time forget it, and then decide again and again. So the item will not be reordered. Multi-period inventory system, decide order size or order term, and then use that order size and order term again and again. There are two types of multi-period inventory system: fixed order quantity model, fixed time period model. Fixed order quantity model, other name is the economic order quantity model, EOQ model, or Q model, because we decide order quantity. And then fixed time period model, periodic system, periodic review system, fixed order interval system, or P system. Decide order term, and then every term comes, and then place order. Fixed order quantity model is event triggered model, and this one time triggered model. I will tell why it is event triggered model with the example, and time trigger model too. Fixed order quantity models. Using this model, we can determine R and Q. R is the reorder point when we place order, and then how many place order, Q. Basic model assumption. Demand is constant and uniform. If we order Q and then receive Q, inventory level is Q. And then if demand is constant and uniform, then this inventory level line is straight, linear. And the lead time is constant. Lead time is the time between order and then receive. Every time, lead time is the same in this basic model. And price, the same every time. Inventory holding cost is based on average inventory. During this period, from Q to 0, average inventory level is Q divided by 2. Average is about here, Q divided by 2. And then based on that average inventory, we can calculate inventory cost, holding cost. And ordering or setup costs are constant, like a shipping cost, every time the same, and all demand for the product will be satisfied. So once we order this many, and then during this term or period, all inventory consumed, and then the level is 0 at this point. Okay, total annual cost. Total cost equals annual purchase cost plus annual ordering cost plus annual holding cost. Annual purchase cost is annual demand, uppercase D, times price of item cost, plus annual ordering cost is D divided by Q. D is annual demand and Q is order quantity. This one from this calculation, okay. If we have D like a 1,000 annual demand, and the order quantity is like Q is 100. So every time we place order 100, then D divided by Q equals 1,000 divided by 100, then 10. This is, if order quantity is 100, then we should place order 10 times to satisfy this annual demand. So this is how many placing order. So this is how many placing order times order cost. So this is annual ordering cost. Then Q divided by 2, this is average inventory level, and then holding cost. So annual holding cost. So using this total annual cost equation and derivative, then equals 0, because if we increase order quantity or volume, then average cost and total cost decrease, and then from this point increase. So the slope of this curve decrease, and then on this point slope is 0. So using derivative, then equals 0, because the slope is 0, then we can get this economic order quantity or optimal order size, that is 2 times annual demand, uppercase D, and then order cost divided by H, holding cost. And reorder point for Beijing model is this one. This is daily demand or average demand, and then lead time. Example, if annual demand is 2,000, uppercase D, and then holding cost H, 2.5. Okay. Then cost per unit, $15. And ordering cost S equals $10. Lead time is 7. Then order quantity equals square root of 2ds time divided by H times 10 divided by 2.5 equals 126.49. So approximately 127. Even this decimal point, after decimal point is a 0.1, still round up. So 127. And then reorder point, daily demand, because this example doesn't say about how many this manufacturer work or store open. So use 365 to get daily demand and times lead time 7, so 38.36. So this is, if we round up, then 39. So it's like that. Place order, and Q is here. Then inventory level down, then R is here. Because of lead time, delivery when the inventory level is 0, receive like this. So this Q model, EOQ model, fixed order quantity model is event triggered model. Event is R. So this inventory level hit point R, reorder point, then place order. So this Q model is event triggered model. And next, total cost. Total cost, annual purchase cost, 2,000 annual demand times order cost. So this is an annual purchasing cost, and then annual ordering cost, 2,000 divided by 127. So this is how many placing order times order cost, $10. So this is an annual ordering cost. The average inventory level, Q divided by 2 times holding cost per unit, so on. If we use this before the round up, 126.49 for Q, then this one, ordering cost and holding cost should be the same because we made that order quantity on this point. So on this point, holding cost and ordering cost the same. So if we use 126.49, then this annual ordering cost and holding cost should be the same. But because we use 127 rounded up amount, a little bit different. And in real world, demand is not constant. Sometimes more, sometimes low, and so on like that. So inventory level line is not straight. Sometimes if demand is slow, then when receive order, then there is no stock. But if more demand, then when receive order, then out of stock. So we need kind of safety stock. So we call this safety stock model because demand is not constant. Even we use this safety stock model, the order quantity is the same, using the same order quantity formula, but difference is order point because we need the safety stock. So basic models, order quantity, the reorder point plus safety stock. So in this model, safety stock model, reorder point equals basic models reorder point plus safety stock. Safety stock equals z-score times standard deviation during lead time. This z-score about the service level or service probability here. Example, daily demand equals 60 units. Annual holding cost is now 50 cents. Desired service probability is 95%, 0.95. If I go a certain store, then if I 100 times, and then if I can get 95 times, then the store's service probability or service level is 95%. If I go there and then 100 times, and then if I can get 100 times, then that store's service level or probability is 100%. So to increase service level or probability of that store, they should have more inventory, higher level of inventory. So this one is about that service level. And then using this one, we can find the z-score. And the cost of placing the order S equals 10, and then standard deviation is 7 units. Lead time is 6 days. Using the same order quantity formula, so 2DS, this one, this example given, daily demand, D bar. So to get annual demand times 365. If example give like 200 days per year, then use 200. 290, then 290. If they produce 290 days, then or consume open 290 days, then use 290 to get annual demand. But this one doesn't say about that, so use 365 to get annual demand times 10 order cost, $10 divided by holding cost, 0.5, and square root, then approximately 936 units. Then to get a reorder point, we need standard deviation during lead time. This formula looks complicated, but this one means standard deviation square sum from 1 to L many. So standard deviation is 7. Daily standard deviation is 7. And then square L many. L is lead time is 6. So sum of 6 standard deviation square. So that is 6 times L times standard deviation square and then square root 17.15. And then we need z-score. This one from normal distribution table using this 0.95. 0.95. Try to find 0.95 from this normal distribution table. This one is attached in your lecture notes. So try to find 0.95, but you cannot find. That case, choose closest one, nearest one. 0.95 is between 0.94520, 0.9505. But this one, 0.95053 is closest to 1. So take that one, and then z-score is 1.65. So use 1.65 here, plug in. So daily demand is 60 times lead time 6 plus z-score 1.65 from this table. And then 17.15 standard deviation during lead time. So approximately 389 units. Questions so far? Okay, good. And the next one is now fixed time period model, P model. Fix the order period, we denote by T. So it's like every 10 days, every 20 days, and so on. So time comes and then place order. So this model is time triggered model. Other textbook, not us, has how to determine the term, but our textbook doesn't include that, so skip that. Then just how many order. This one also similar to safety stock model. So using this safety stock, Z, standard deviation during the term T plus TL period. So Q equals daily demand times term, fixed term plus lead time plus Z score about service level or probability and standard deviation during T plus L minus, if there is inventory on hand, then subtract. Example, daily demand is 10 units, lead time 14, 150 units on hand. Standard deviation is 3 units. The desired service probability or level is 98%. Review period is 30. This is T. So using this, first we need standard deviation T plus L. So standard square root of T plus L times standard deviation square, 30 plus 14 times 3 square equals 19.9. Then Z score, 98%. So 98%, we don't have, we cannot find an exact 98%. If we use Excel, then we can find the exact Z score, but from this table, 9.97982 is closest one, so use this Z score 2.805. Plug in 10 times 30 plus 14 plus 2.5 Z score from table times 19.9 standard deviation minus 150 because 150 on hand. So order quantity is 330.79, round up 331. I think that's all for chapter 12. And then you have another assignment. This one individual. Assignment 12, chapter 12 on Moodle. Download this file. I will open. This one is an inventory system, ordering system. So using EOQ model, find the order quantity and total holding cost, ordering cost, find and reorder point. This one is a safety stock model. So using safety stock model, with this 99% probability. And then here it says 200 days. So when you get annual demand using this number, so daily demand is 75 times 200 is annual demand. Complete and upload here your assignment, and due is next Tuesday. So you have 2 assignments. First one is finding supply chain management case, summarize. And then the other one is this one. Okay, any question? Okay, that's all for today. I prepared. Next 2 weeks in class. So if you want, come to class physically. See you in class and online next week. Okay, that's all. Good night and see you.
All right, take care. Thank you.
Good night. Take care.
Okay, thank you.
Thank
Good
you.
night. Thank you.
Thank you, Dr. Kim. Good night.
Thank you. Good night.
Thank you, Dr. Kim.
Thank you.